Good morning, everybody. Today we're going to take a look at simplifying rational expressions. Okay, remember rational expressions are just fractions that typically have x's in numerator and or denominator. Okay, so if you look at part B there, x squared minus 9 over 2x plus 6, that's an example of a rational expression. Simplifying a rational expression into its lowest terms is an extremely useful skill. Okay, simplifying in general, very helpful. Its algebra is based on how we simplify numerical fractions. The basic principle is developed in the first exercise. Recall that to multiply fractions, one simply multiplies their numerators and denominators. In other words, to multiply two fractions together, you multiply the tops together, you multiply the bottoms together. Simplify the numerical fraction 18 over 12 by first expressing it as a product of two fractions, one of which is equal to 1. So for a fraction to equal 1, what does that mean? Well, the numerator and denominator must be the same. All right, so let's take a look at 18 over 12. I could say, for instance, 18 over 12 is equal to, say, 6 times 3 over 6 times 2. And then what I can do is I can break that into two separate fractions. I can think of that as, instead of 6 times 3 over 6 times 2, I can think of that as 6 over 6 times 3 over 2. And so now we've done what they asked, basically. We've written this as a product of two fractions, one of which is equal to 1, right? 6 over 6, anything divided by itself is 1. And so in doing that, we have simplified this into 3 over 2. Because 1 times 3 over 2 just leaves us with 3 over 2. Okay? And so the idea is similar when we want to extend that to rational functions. In part B, we're going to simplify the algebraic fraction x squared minus 9 over 2x plus 6 by first expressing it as the product of two fractions. In other words, factor it, okay, one of which is equal to 1. Looking at the numerator, we have x squared minus 9, so that looks like a difference of squares. In the denominator, we have 2x plus 6, which seems to have a greatest common factor of 2. So in factoring, we're looking at x plus 3, x minus 3 in the numerator, and 2 times quantity x plus 3 down below. Okay, and again, the next step, not completely necessary, but I will express it as the product of two fractions. Moving forward, we're not going to typically do this, but what I'm going to do is I'm going to rewrite this as x over 3 times x plus 3 over x plus 3 times x minus 3 over 2. Okay, and so I just broke that into the product of two fractions, the first of which is 1. X plus 3 over itself is 1. And that leaves us with x minus 3 over 2. Okay, now in general, what you'll see me do is after I factor, I will simply cancel common factors in numerator and denominator. And whatever's left that we can't simplify is our final answer. All right, every time we simplify a fraction, we're essentially finding all common factors of the numerator and denominator and dividing them to be equal to 1. Key in this process is that the numerator and denominator must be factored and only common factors cancel each other. This is true whether our fraction contains monomial, binomial, or polynomial expressions, whether there's one term, two terms, or multiple terms up in the numerator and denominator. Okay, but key is with monomials, as we're going to look at in exercises 2 and 3, we have one big term in the numerator, one big term in the denominator, and that's basically just simplifying your numbers, your coefficients, as well as your powers of x, y, or whatever letter may be there. Okay, factoring will be much more common as we get into like example 4. And 5 and 6, okay, and so on there, where we have polynomials, okay? So if you can factor, factoring is the first step, all right? But again, with monomials, no such factoring is needed. So let's take a look at exercise 2 here. So part A, we have 3x to the 5th over 3x to the 5th y to the 6th over 6x to the 8th y cubed. So on one hand, we'll simplify the coefficients, 3 over 6, and on the other hand, we'll simplify the powers of x and y. Different ways to go about this, but I'm going to go 3 over 6 is equal to 1/2. And when we simplify exponents, when we divide with exponents, we subtract, right? So x to the fifth over x to the eighth. 5 minus 8 is negative 3. And for y's, 6 minus 3 is 3. Okay, and so one way we could write this is 1/2 x to the negative third, y to the third. Or we could put that x to the negative third back in the denominator with the 2. So it might look like this, y cubed over 2x cubed. Okay, just keep in mind negative exponents, put those variables back in the denominator. Okay, looking at part B, 20 over 4 is going to give us a 5. When we do the subtraction of the powers of x, we're going to be left with x to the eighth, and the y to the eighth is just going to stay. And looking at part C, 7 over 21 will become 1/3. We're going to have x to the negative second, y to the negative seventh. And again, if I want to clean this up a little bit, the 3 is in the denominator, the x and the y will go in the denominator because they have negative exponents. Okay, moving on to number 3. Which of the following is equivalent to 10x to the sixth, y to the third, divided by 15x squared, y to the sixth? 10 over 15 has a common factor of 5. And 10 is 5 times 2, and 15 is 5 times 3. So simplifying will leave us with 2/3. When we subtract the powers of x, we're going to have x to the fourth, and when we subtract powers of y, we'll have y to the negative third. So writing this out, we have 2/3, x to the fourth, y to the negative third. And looking at answer choices, we're going to keep the 3 in the denominator. We're going to put the y in the denominator with it. So we're looking at 2x to the fourth over 3y cubed. When simplifying rational expressions that are more complex, always factor first. Then identify common factors that can be eliminated. Simplify each of the following rational expressions. Part A. All right, we have a trinomial x squared plus 5x minus 14 over a difference of perfect squares, x squared minus 4. So think a moment about how to factor that. And up top, we need numbers that multiply to negative 14 and add to positive 5. So we're looking at positive 7 and negative 2. Down below, we have a difference of perfect squares. That'll be x plus 2, x minus 2. From here, we can see what the x minus 2's will cancel, and we'll be left with x plus 7 over x plus 2. And we're just going to make a note that this is for x not equal to positive 2. That's what we canceled away. When x equals positive 2, that makes the original function undefined. Okay, so we're just going to make a note here that when we simplify with these polynomials, okay, we're just accounting for the original value we canceled away that will make the denominator 0. Ultimately, the x plus 7 over the x plus 2 is our final answer. Okay, I'm just including a little piece for the domain here. In part B, we have a difference of perfect squares, 4x squared minus 1, divided by something with a GCF, 10x minus 5. Up top, think about the factoring, 2x plus 1, 2x minus 1. Down below, we have a GCF of 5, leaving us with a 2x minus 1. We can see that the 2x minus 1's will cancel, leaving us with 2x plus 1 over 5. Okay, and again, I'm not going to worry about that domain issue that I talked about in part A. It's not ultimately that important. It's not what we're here to do today. Okay, so don't worry about that. Moving on to part C. We have a trinomial with a leading coefficient greater than 1, 3x squared plus 14x plus 8, over again a difference of perfect squares, x squared minus 16. Up top, I think we're looking at the A times C method, which would be 24. So we need factors of 24 that add up to 14. 12 and 2. Okay, so off on the side, I'm going to do the factoring for the numerator. So we're going to have 3x squared plus 12x plus 2x plus 8. Now I'm going to factor by grouping. The first group has a GCF of 3x. The second group has a GCF of positive 2. Completely factoring, we're going to get a 3x plus 2 in x plus 4. And that was in our numerator. The denominator, x plus 4, x minus 4. We can see that the x plus 4's will cancel, leaving us with 3x plus 2 over x minus 4. Okay, we need to be careful when we have reversed subtraction in numerator and denominator. It's one thing if we have reversed addition, such as 1 plus 4 over 4 plus 1. That just becomes 5 over 5, which is 1. And because addition is commutative, it really doesn't matter which order we add things, but subtraction is not commutative. So looking at number 5, simplify each of the following. Notice that in all three cases, we more or less have the subtraction of two numbers on top and the reverse of that subtraction down below it. 9 over 6 over 6 minus 9. 15 minus 3 over 3 minus 15. A minus B over B minus A. In each case, we have something in the numerator and the reverse of that difference in the denominator. Let's see what happens. In part A, 9 minus 6 up top is 3, and 6 minus 9 is negative 3. Leaving us with negative 1. In part B, 15 minus 3 is 12, 3 minus 15 is negative 12. This time we're getting positive 12 over negative 12, again, negative 1. So as you may suspect, anytime we subtract two numbers and we reverse the order of that subtraction on top and bottom, we're going to be left with negative 1. So part C, A minus B over B minus A, that's negative 1. Here's how. I'm going to leave A minus B on top alone, but I'm going to reverse the order of in the denominator. I'm going to write that as negative A plus B. Okay, that's still the same as B minus A in the bottom. I just reordered that negative A plus B. Now I'm going to factor the negative out of the denominator. Notice in doing that, we end up with, in the parentheses, A minus B. If you distribute that negative back through, you're going to get negative A plus B back, which we began with. But now, since we have A minus B on top and bottom, we can cancel, but we're not left with 1 over 1, we're left with 1 over negative 1. And at the end of the day, that equals negative 1. On a side note, notice we canceled everything out of the numerator. That didn't give us 0 at the end of the day. When you cancel something away completely, it leaves you with the 1. Anything divided by itself is 1. Try to remember that, okay? So when you completely cancel something away in the numerator or denominator, you don't get 0. You're left with the number 1. In any event, the big picture here is that when we divide and we reverse the order of subtraction, we got to account for that with a negative 1. Let's take a look at example 6, which of the following is equivalent to 2x minus 10 over 25 minus x squared. So again, if we want to simplify this, as we can tell what we're doing by the answers, just smaller examples of the fraction, that means we're simplifying, okay? We're going to factor, and we'll see what we get. So up top, we have the GCF of 2 with an x minus 5. Down below, we again have a difference of perfect squares. Notice that the 25 comes first. It's not going to be x plus 5, x minus 5. This time it's going to be 5 plus x, 5 minus x. Okay, now carefully looking at the factors, we don't have anything that's exactly the same on top and bottom, but we do have reverse subtraction. We have x minus 5 with 5 minus x. And based on what we just did up above in number 5, what's going to happen? Well, they'll cancel, but we won't be left with 1. We'll be left with negative 1. Now, I typically throw the negative in the numerator. And so cleaning this up, I'm going to write this as negative 2 over 5 plus x. And looking through the choices, that is the same as choice 1. Again, the x plus 5 can be flip-flopped without any consequence because it's addition. And number 7, which of the following is equivalent to x squared minus 6x plus 9 over 18 minus 6x? Why don't you pause and give it a try and then play, and we'll see if we get the same thing. All right, up top we have a trinomial. We need numbers that multiply to 9 and add to negative 6. That ends up being x minus 3 times x minus 3. You could write it as x minus 3 squared if you wanted to. And down below, 18 minus 6x has a GCF of 6 with a 3 minus x left over. So similar to question 6, we do have reverse subtraction in numerator and denominator. The x minus 3 with the 3 minus x will cancel, leaving us with a negative 1 out in front. You can put the negative in the numerator or the denominator or out front. In number 6, I put it in the numerator. In number 7, I'm just putting the negative out front, and then I'll figure out what I need to do to match my answer choices. In looking at my answer choices, I don't see one that has a negative out in front of the entire fraction. Chances are they distributed it to the numerator. Okay, again, they're just playing around with the way they've written the answer choices. While choice 1 looks very close, it is not the same. Anybody see it? It's choice 4. They wrote that instead of negative x plus 3 as 3 minus x over 6. So just be careful with that stuff, and if you have any questions, please shoot me an email. Give the homework a try, and then check your solutions. Have a great day.